Hello everyone, in this video we are going to see about the operations in stack. We all know that stack is a linear data structure which has the operation of order of last in first out, that is LIFO. What is LIFO is the elements which is put inside the stack will be, which is first put can be taken only in the last, and the last element can be removed first. That is the order of transacting the elements or order of accessing the elements. So it is a linear data structure that follows a particular order in which the operations are performed. The order is either LIFO or FILO. Mainly, the following three basic operations are performed in the stack. The first one is push. Push adds an item into the stack. If the stack is full, then it is said to be an overflow condition. That means we cannot add an item to a full stack. Any stack has some capacity, and if we try to add more element beyond the capacity, then that condition is called as an overflow condition. Same way, in the pop operation, we have a condition called underflow condition. What is underflow is, and before that, what is pop is, removing the element from the stack is called pop. So now, if at all you want to try, we want to remove the element from an empty stack, which is not possible. Okay, so when you say the stack is empty, no element is there. If you try to access an element or to remove the element from the empty stack, that condition is called as an underflow condition. And the next one is the peak or the top. This returns the top of the stack. Actually, this top is the register which always shows the top of the stack. That means currently any element will be, the top element will be always focused. So there only that's the last position where the push and the pop can take place. So when you use the function peak or top, this returns the top element of the stack. That means which element is in the top, that is returned by this function peak or top. And then one more function called isEmpty. This function returns true if the stack is empty, else false. That means if we want to check whether the stack is full or empty, we use the function isEmpty or isFull. So if isEmpty is true means, so naturally the stack is empty, otherwise it is false. So let us see how this stack can be represented in the memory. So this is the stack, representation of the stack in memory. So we have push and the pop operation. Push inserts the elements into the stack, so the arrow is downwards, and pop removes the element from the stack, so it is away from the stack position. And now top is the top of the stack, which always points to the current element in the top of the stack. So this is the element, that is whichever the pointer, the top pointer shows, that is the last element which can be popped out. So once you push any element, the top is incremented to the newly pushed element position. So this is the top pointer, also called as a stack pointer. So now let us see how the implementation of the stack can be done. Actually, what is implementation is how this data structure can be represented and how the operations can be performed. So that is called as an implementation of anything. So now we are going to implement the stack in two different ways. One is using the array, next is using the linked list. So we all know that array is a data structure which has contiguous memory location, and whereas linked list is a data structure where the memory locations are scattered all over the memory, and the pointer is used to follow the consecutive elements. We have seen in the previous slides and the previous videos all about the arrays and the linked list. So let us see how this stack can be implemented both through arrays and the linked list. Okay, so now as we have the main operations of pop and push of the stack, let us try to implement this push and the pop operation using the array and the linked list. Let us also see an example of how this operation is done. Now let us see the diagram. This is the diagram for the pointer representation of the linked list representation of a stack. So here generally in memory, this is the stack representation. Just imagine, so stack element has 2, 7, 6 and 4, and now the same element, this is the stack element, representation. Now using the pointers or using the linked list, how it is represented in the memory. So this is the next diagram. Okay, this is the array representation and this is the linked list representation. So we know that array is a consecutive storage location, okay, or is a continuous memory addresses. So now here, this is the stack. So we are taking a stack of capacity 4 which contains the elements 4, 6, 7 and 2. So now let us see how this array represented is done by for the stack and how the linked list representation is done for this same stack. Okay, so as the stack pointer which just having a memory address, just assume 206. So 206 is the address of the top element of the stack. So when the stack pointer always points to the top of the element, top of the stack. So the address of this 4 is 206. So now stack pointer contains the address 206. So this is the room for growth, means we can keep on adding more and more elements in the stack using the push operation. And now next, since it is the contiguous memory location, now the next element is stored in the position 205, the sixth element 6. Next is the 204, the element is stored as 7, and 203, the element stored is 2. This is the array representation of how the stack is implemented or stack is represented. Now the same stack is represented using the linked list concept. We know that linked list consists of nodes, contains the data and the address. So initially it is assumed that the stack pointer, the top address is 709. So 709 is the stack pointer which points to the top of the stack. Now that is the element 4. So now the 709 points to the element 4 and the next element of 4 is 6. To the next element to 4 is 6, and now we have to follow the address of this 6 using the pointers. How it is done? Now 4 is the first element which contains a address section in the node. It is a data and this is the address node. We know that the linked nodes consist of data field and the address field. Here 4 is the data field and 351 is the address field. So now this 351 says that the next element to 4, which is 6, is stored in the 351 location. So the system will search for the 351 address. So this is the 351 address. Now 6 is stored. Now to follow the next element 7, it has to follow the address of the node 6. What is the address of node 6? 103. So the system has to search for the location 103 in the memory. It found out 103 as the memory location. Now there the element 7 will be stored, and then after that 2 is the next location, next element, and how it is traced? It is by the address field of the 7 data. So now 688 is the address shown in the data field of the address field of the data 7. So 688, the system will search for 688 location and there it will store the number 2, and after that there is no element in the stack. So the address consists of a null pointer. This null pointer always points to the end of the stack. So this is how the array and the linked list are used to represent the stack. Now let us see the operations of the stack, the push and the pop using the array and the linked list. So now we know that push is the operation which helps to add the element in the stack. So how to add the element in the stack? It is done in two steps. What are all the steps? First, increment the variable top so that it can now refer to the next memory location, because we have to add new element. So in order to add new element, we have to make memory for the new element. So that is done by incrementing the top variable. Top is equal to top plus 1, and then that element is put at the incremented top. This is referred to as the adding new element, also called as a push operation. Now the algorithm says stack is overflown when we try to insert element into a completely filled stack. Therefore, we cannot push more element in the full stack. It will be an overflow condition. So how the algorithm goes? It begins with the condition if top is equal to n, then stack is equal to full. That means the elements are occupied, all the memory space is occupied by the elements in the stack. So top is equal to n. The stack is full. If not, we have to increment top is equal to top plus 1 to get the room for the next element. We are going to push new element. So we have to increment the top is equal to top plus 1. So once increment, we have to put the item which we are going to push the new item into the stack position, which is in the top of the stack. So stack of top is equal to item, and then we have to end the procedure. So this is a simple step by which the stack push operation is done. The same way the pop operation. The pop is a deletion operation where it removes an element from the stack. So as it is very clear that we cannot remove an element from the empty stack. If you try to do that, now the condition is called as an underflow condition. So for that, the algorithm says begin if tap is equal to 0, then stack is empty. That means the stack has nothing to remove. Otherwise, we have to remove the element. Which element? Only the top can be removed. So stack of top is equal to item. And now we have to decrement the top pointer. In push, we have incremented the top pointer. In pop, we are decrementing the top pointer, and then end. So this is a simple algorithm. Just we have to check the stack is empty or not. If it is not empty, we are removing the element from the top and put it in the item. And now top is equal to top minus 1 to get the next element. So this is how the push and the pop is done. It is shown in the diagram as below. Now the initially stack is empty. We are pushing element 5. It goes to the position 1, and then we are pushing one more element, that is now the top value is 6. Now when you say pop, the last element will be popped. That means 6 will be removed. When you say again pop, the next element, which is 5, will be removed. So this is how the push and the pop operation is done in the stack. Now let us see the same operations push and pop and how it is done using the linked list concept. So we know that linked list consists of nodes, and the node consists of the data and the address field. So first we have to check whether the space is available to push any new element. For that, the condition is if avail is equal to null. Actually, what is avail is a variable which refers to the freely available memory spaces. If avail is equal to null, then write overflow and exit. That means we cannot push more element and you have to exit the algorithm. Otherwise, remove the first node from the avail list. So avail list consists of collection of free nodes, and from that free nodes, the one node will be removed and it will be attached to the stack. So how it is attached? Set new is equal to avail and avail is equal to link of file. So we know that link is the link, that's a pointer that connects the two different nodes. So we are setting the value avail into as a new value, and the pointer of avail will be the link of avail. So now we have made a room for the new node, so we have to copy the item. Item is equal to info of new is equal to item. That means we are copying the new item into the position which we have created now from the avail list. And now set link of new is equal to top, because now we have pushed one more element. Now the top will be incremented by the link of the new element. And now set top is equal to new, because now the top is reset to the next position which is new. So that's all the logic. Exit, we have to exit the algorithm. So this is how the push operation is done using the linked list. Actually, what is the summary here? Get a available free node from the available pool, and then you set the pointer and you attach the data to the address of the linked node, avail node. So that's all. We are copying the item into the available new node and we are incrementing the top position as top is equal to new. So the same way we have to do the pop operation also. Okay, this is the pop operation. Okay, this is pop actually. So pop link stack means here we are going to, the algorithm consists of info link top avail item. Now the stack has to be removed. So how to remove an item? If top is equal to null, then write underflow and exit. That means if it is null, we cannot remove the element. Just type the message underflow, we cannot remove. Otherwise, what we can do, we have to get the element of the top, which is the information field, into the item. That means we are removing the item from the top of the stack. And then temp is equal to top and top is equal to link of top. Now we have to decrement. Now the top is set to the new element because one element we have removed. So it has to be changed as an, the pointer has to be connected to the next element. So now set link of temp is equal to avail. That means this avail is the empty space now which is got by after removing the top element. So we have to replace, or we have to return back the available place available to the avail node, because while inserting or pushing we got the node from the avail list but in the case of pop operation we have to return back the memory space which is created by removing the element from the stack. And now set avail is equal to temp. That means now the temporary variable now contains the value from the avail, which is the node got from the avail list. So that's all you have to exit the algorithm. Now let us see with the example how it is done. So now here the stack size is 0 initially, top is nothing. So when you give push, 17 is pushed, and now stack size becomes 1 because one element is pushed. Now this pointer is incremented to 17. Now again when you give push of 23, now the element is pushed to the top position. So 17 will be in the bottom and 23 comes to the top. And now when you give the, now stack size becomes 2 because it contains two elements, 17 and 23. Now we have to give the pop operation. When again if you give push, it is added. Now stack size is 3, so we are having the top element is 97 because 97 is the recently pushed element which is in the top. And now we have to, if we give pop, it will pop only the top element. Now the top element is 97, it is removed. Now the stack size becomes 2. Okay, so now 97 is removed, so only 23 and 17 are available. So this is the way the push and the pop operation is done using the linked list concept. So that's all the operation of push and pop using the array and the linked list concept. Hope it is easy to follow, and thanks for watching.